Assalamualaikum warahmatullahi wabarakatuh. My name is Sinta Safri Yunus. I'm from class D. Today I want to experiment to which is stability of floating bodies. Firstly, I want to say about the objective. First, the objective is to determine how the floating characteristic of a pontoon change as it is linked with wind and sails. And the second is to determine the metacentric type of a pontoon and to investigate its stability. So we go to the next, which is the apparatus. As you can see, the number one is the mast. This is the mast, and number three is the sliding mast, which is sliding mast with up and down. So and then the linear scale at the bottom. This one is the linear scale, and this one is the adjustable mast. And as you can see, this wood is the transverse shaft. And the number six, the square one, this is the pontoon body. The dimension is at 315 times 180, and this one is the plumb line, and the spring, and the last one is the pendulum. Okay, we proceed to the next part, which is the procedure. So firstly, you have to open the transverse adjustable mast and measure the weight of the adjustable mast. So this is the transverse adjustable mast. So you have to open it and measure the weight of the adjustable. So the weight adjustable mast is 219.1 grams. And then you have to reassemble the mast to the power to measure the whole set from power to body students. Overall, you have to calculate measure the weight. And the weight of whole set from 240 is 1,988 grams. And the next step is you have to position the sliding mast. This is the sliding mast along the mast such that the center of gravity occurs at the top of the pontoon. This can be determined by using either a knife, knife edge, or by suspending from a light string around the mast. So you have for this step 1 and step 3 should be done prior to the experiment, so you can proceed the experiment smoothly. And then after you have to do the step 1 until step 3, you have to fill the water. This is the sink, so you have to fill the water, and then you take your apparatus and put the pontoon and ensure that adjustable mast is in the central position. And then after this is you have to float the pontoon and the adjustable mast in the center. This is the adjustable mast. So as you can see, there is a soft item that will show at the reading at the zero. So you have to watch this carefully to avoid the measuring error. And then you have to check the zero letter between the plumb line and the scale. So this is the plumb line. This is the plumb line. So you have to check the zero letter. After that, you have to move the adjustable mast. So this is the adjustable mast. So you have to move to the right for 10 mm. So at the scale, there's the scale. So you have to measure at the 10 mm, and then to the end of the scale. And then you have to note the angular displacement of the plumb line for each position. After that, you have to repeat for the movement of the adjustable, which is before this you move it to the right, and then you have to move it to the left. That's same as before, you for 10 mm increment to the end, and then you have to repeat the adjustable mast to the left of the center. So with the exception of rigging the adjustable weight and emptying and refilling the volumetric tank, repeat the experiment step 5 to 7 for the sliding mast at different height of the mast for different center of gravity, which is this is the sliding mast. So you have to move it up, and you have to take the reading also. So they give the height, which is 50 millimeter and 100 millimeter for different. So this is for different centers of gravity. And after you move up the sliding mast for the different height, it will tilt like this, and then you have to record the reading. So this is the table. So you have to record all the reading result sheet at table experimental value, experimental result, and then you have to repeat for movement of the adjustable mast to the left center, and then you have adjustable the weight, and you have to record the reading, the result sheet. So for the example, based on table 2, the first column in the table is the parameter. So this is the parameter, and which represent the increment of the adjustable weight. And for an example, sample data experiment and increment of 50 millimeter to the right, and with 0 millimeter, 50 millimeter, and 100 millimeter height sliding lines are used. And then you have to record you have to measure the displacement of the pendulum in millimeter for each height, which is 0 millimeter, 50 millimeter, and 100 millimeter. So after that, as you can see, if you move the center of the gravity, which is you move up the sliding mass, the tank will tilt like this. And then when you take the reading, you have to make sure that your eyes is perpendicular to the reading to avoid the error. So when you have to set the sliding mass at certain height, you have to do it slowly, so you can get the correct measurement. And then you have to the distance between the pendulum to the mass. And the last procedure is when you have completed all the experiment, you have to open the valve B7 to release the water in the sink, and then the experiment is done. Okay, next we go to the data analysis. So now I want to build a table by using the Excel. Now from the table given, I will do the draw. So the conclusion for this experiment, which is the stability. So conclusion is finally we may say that our experiment was successful in achieving this goal, unfortunately due to the several factors leading to inaccuracies such as complicated and systematic error. The experimental and theoretical values obtained for the result are slightly different. However, for submerged body with the center of buoyancy above the center of gravity, the body will return to its original position due to a few moments caused by wake and buoyant force. The meta center should be higher than the center of gravity for a stable contour. This is because the centers of gravity and angle influence the meta center height due to practical consideration. Therefore, the metacentric height will decrease as the center of gravity rises. This indicates that the contour is become less stable. Furthermore, when it comes to angle, the smaller the angle, the higher the meta center. Therefore, it is more stable. And the contour stability will be higher if the meta center is substantially higher than the centers of gravity, and it will generate a short period of oscillation, resulting in the discomfort and in undue stress on the contour structure. This hypothesis is mostly applied in the construction of passenger ship. The ship should be safe and comfortable to travel on. Next, we go to the recommendation for this experiment, which is we can determine the position of sliding mass, such as the center of gravity at the top of the pontoon by using a knife edge or suspending from a light string around the mass. And we also can decide a decimal place to make sure the angle for each height is accurate. So this is for when do a calculation. And the next for the application of stability is for the floating of ships, submarines, which is the balance tanks in submarine is filled with seawater, so it will sink. And the next is application is iceberg floating underwater, as when someone is swimming in the pool or sea, and when they're swimming. And then the hot air balloon. And that's all from me. Thank you.